Welcome to the Oxygen Alliance YouTube channel, where we bring you videos on installation, maintenance, and various trainings on oxygen equipment and devices. If you have comments and or questions, drop them in the comment section below or write to us info@oxygenalliance.org. Remember to like our videos, subscribe to our channel, and hit the notification bell.
Hello everyone, welcome to another session of Partner Talk brought to you by the Oxygen Alliance. My name is Foster Sentala and I am your host today. I am joining this call from Lilongwe, Malawi, where we have offices of the Oxygen Alliance. If you're just joining us now, may you also type your name and your location in the chat so that we also know where you're joining us from. If this is your first time to join us, or maybe you're not included in our emailing list, you can also drop your email in the chat so that you are added to our Oxygen community. Today, we have a beautiful session that the Oxygen Alliance is bringing us, as it was communicated earlier on a few weeks ago, that we will now divert into doing the Oxygen Talks in series called Theme Topics. Today marks the day that we start our theme topics. And as communicated, the first theme topic of this year is the medical imaging technology. So today we'll begin this theme topic by diving deep into the X-ray imaging technology. And ladies and gentlemen, today it is my great pleasure to introduce you our speaker for today, who is none other than Mr. Henry Kuwumulo. So Henry is currently finalizing his PhD in biomedical engineering at Makerere University, where his research focuses on cutting-edge advancements using nanotechnology in medical imaging for cancer treatment. He is a biomedical engineer, and also he works as a biomedical engineering lecturer at Makerere University in Uganda. So join me as we welcome Henry Kuwumulo as a presenter for today's talk, where he will be diving deep into the technology behind X-ray imaging equipment. At this point, let me hand you over to our speaker for today, Henry. Over to you, Henry.
Thank you so much, Foster, for your kind introduction. So, hi everyone. Welcome to this Oxygen Alliance Partner Talk. Thanks so much, Foster, for inviting me, and the Oxygen Alliance team for inviting me in this first section of our series. And as Foster said, I'm Henry Kuwumulo. I'm a lecturer at Makerere University. He talked it all, I feel. This talk is intended for X-ray imaging equipment, as we shall see or as we shall hear. And of course, we have a brief outline given our time where we shall basically talk about the equipment planning, the X-ray construction, the equipment common faults and troubleshooting, the preventive maintenance theory. This involves replacing some components and calibration. And of course, as you know, X-rays are hazardous. So there is quite a lot of safety precautions one needs to take take precaution about. And then, of course, this applies to both the user and even the patient. And then, of course, the performance monitoring. Those are some of the hints that we shall talk within this time. Of course, as a general discussion, I was told that the audience involves quite lots of technical people who are more skilled than me. So it's more of a discussion, maybe, as you'll hear, but it's all for us to learn. So let's just dive in by starting with equipment planning. So X-ray machines being quite so vital and sometimes they involve a lot, and even of course they are hazardous conditions. One requires to plan, and of course this planning has to really be oriented to the X-ray type that you hope to get, and of course even its after effects after obtaining it. So this involves even budgeting and financing, the technology assessment, the procurement, the installation, the training, the operation and safety, the maintenance. But all this needs to create awareness and also to monitor and evaluate this machine as it gets to be installed and as it gets to be used. And of course, even decommissioning later on. So this equipment planning is very important because it allows monitoring the implementation. It helps to review the past performance or the problems or the needs. It helps to identify the solutions and set specific goals. It also prepares for an annual action and also plan for delivering improvement. So it's very essential for one to plan for an X-ray equipment that he or she hopes to procure. So you have also to be aware when the best time is to bring up an issue during the planning. So all of this has to be embedded in the plan so that you are not taken unaware, especially after investing a lot of money in buying an equipment. So we have various types of these X-rays that most of you have come across. We have those that are standard X-ray systems. These ones normally have a table, and then of course this table is for full body exams, and then there is a chest stand. So the chest stand, so we normally call that standard. And then we have those that are mobile, and these go to the patients. So they have a detector plate which is positioned normally in the bed or under the bed or under the patient, so to provide that mobility effect. We have the mammography systems. These are normally for scanning the breasts and sometimes for cancer. Then, of course, we also have the dental X-ray types, where a small piece of film is put just behind the teeth into the mouth, and then you can be able to X-ray and get the dental stature of the patient. So the construction is generic, but of course what changes is basically the design. So depending on the functionality of the X-ray system, you'll always have these similar components performing the same functions, but the design will slightly change depending on how the machine is going to be applied. But you always have an X-ray machine with a tube, a generator, a collimator, high voltage cables, stand, a desk, a detector, and then a control desk. So this is, of course, quite an old model, but it shows most of the basic. Of course, there are other parts with, of course, the advanced X-ray systems, but those are additionals just to improve on the performance. But these can be the basic parts of an X-ray machine. So we can also dive deeper into some of these different parts, starting with the heart of an X-ray machine. So the heart of an X-ray machine is a tube. So this dictates it all. It dictates the X-ray dose that comes out, and of course, how this dose is going to affect the patient and so on. So we have basically two different types of tubes, and sometimes these also give the name of the X-ray machine to be used. So the tube dictates a lot. So these different tubes have a different anode construction, focus port, maximum heat capacities, tube housing style, and even insert materials. And we basically have what we call a stationary anode. We shall talk about it later. And then, of course, what we call a rotating anode. So these are different designs of the tube, of course, that dictate the functionality of an X-ray machine, as we shall see later on. So still under the tubes now, we normally have, this is a schematic of the tube, but we normally have a high voltage transformer supply, which of course we shall also talk about briefly. And then of course the low voltage, which is a filament transformer, which we shall also talk about. But these are also very important aspects of the schematic of an X-ray tube. Now, of course, we've just talked about the tube as being the heart of an X-ray machine, but it has a component that we call a rotor control. So this rotor control basically just helps to rotate what we call an anode. So the tube has an anode, and of course, this anode is affected by what we call a rotor. And this rotor, of course, has different speeds of rotation. So there are low-speed controllers, and then, of course, high-speed controllers. So these low-speed tubes are normally for general radiography, like the chest, or simple radiography. And these can go up to around 3,000 RPM. And then there are those that are high-speed, and these are for special exams like fluoroscopy, and these can run up to 10,000 RPM. And of course, this rotor controller, as it rotates, of course, there's what we call an interlock circuit, and this sometimes inhibits the exposure if at all the circuit fails. And so sometimes it's also very sensitive always to check on this circuit, especially if at all the rotor is not well effective. This can also be governed by the generator, and this can be a separate electronic cabinet that can also control the rotor. So still the heart of an X-ray machine being the tube, of course, this is the pictorial kind of representation. So the tube has mainly two very important parts, and that's the anode and then the cathode. And then, of course, it has the rotor, which we've talked about, which is an anode disk rotation mechanism. And of course, both of these are engraved in a vacuum, which we call a tube insert. So this insert has a vacuum, at least to effect the X-ray production. So physically, this is how the tube looks like. And of course, we shall talk about the high voltage cables that come into this tube. And there's a section where the X-ray comes out after hitting the rotating anode. So basically, this is the tube that we all know about. And one has to always be precautious to prevent this tube from mechanical shock, because if at all it gets mechanically impaired, then of course it can cause leakages to the X radiation. So still in the tube, we have, of course, high-end X-ray tubes where the anode is rotating. And this, the effect that it causes is the enormous amounts of heat, that get generated. So there is a need always to cool, sometimes with water or with oil, for this heat that is generated within the tube, because these temperatures, which is 3,000 degrees, are quite high enough. And so they have to be catered for. And of course, schematically, this is what happens within the X-ray tube. Of course, there is a low voltage kind of effect that gets onto the filament, and then the filament gets heated. And as it heated, it generates electrons, which of course flow to the anode. And then of course, this is by, of course, a voltage. And then of course, as they flow and then they hit what we call a target or focus spot, it's a very small percentage, something like 1% or less of these X-rays that come out, but the rest is converted into heat. So as these X-rays come out, they pass through a window, and then they get to the collimator and then to the patient of interest. But of course, the rotation is affected by the rotor, as we have just talked about it. And this rotor helps Of course, it also has another function of being able to handle this, to distribute this heat, which is produced by these high temperatures, to have an even distribution within the vacuum so that it doesn't hit at one spot and then, of course, affects that spot in the long run. So basically, that's how schematically the tube is. Now, one of the most important thing is troubleshooting this X-ray tube. How do you tell that this tube is really aging or it has an issue? Now, of course, on average, depending, of course, on the use and the design of the tube, these tubes normally, they can be used for 2 to 4 years or longer, of course, depending on the use. And some of these, the tube components can, of course, break down, and this could be the rotor bearings and the filament failure and the anode and so on. But sometimes there are visual checks that you can always tell that the tube is fading, and one of them is, of course, to listen to the rotor, because as you expose, normally the tube makes some noise as it rotates. So sometimes if you hear this sound of rotation being compromised, sometimes you can get to know that this tube is getting impaired. And sometimes when you expose, especially in a dimly lit room, you can always see some intensifying screen glowing. So if at all you don't see that, then of course that can also tell you that probably this tube is not doing its function. And of course, the heating. So if at all the housing also gets red hot or too hot after maybe a short time, which is unusual, then that can also indicate a problem or a defect with the X-ray tube. So these are the different parts which we shan't go much in detail. But one thing that we have to know is there are no field serviceable parts, unfortunately, inside this tube. So this is just because replacing these tubes is not possible without expensive and specialized equipment, plus the knowledge, of course, of working with high voltages and radiological recalibration. So that's why we don't go further to opening. So most of these tubes, of course, they are taken back to the industries or the manufacturing plants to be dealt with because of those kind of intricacies that they have. So in addition to the tube, we have what we call a high voltage generator. So this generator creates the high voltage that we have talked about, and this accelerates the electrons that travel to the anode from the cathode. And this voltage can shoot to around 80 kV, which is really high. And of course, in addition to this high voltage, there's also, the generator also creates low voltage. And the main essence of this low voltage is basically to provide the current that is used to heat up this filament that we saw previously. And as it hits the filament, electrons are generated and they get ready to move to the rotating anode. So this generator has what we call high voltage cables. So these are, as you hear high voltage, of course, they support this high voltage that is generated, and they get connected from the X-ray generator to the X-ray tube. So they are really thick cables, as you can see, but all that is to support the high voltage generation. So in brief, we have a simple schematic of an X-ray generator. And of course, this cuts across all generator types, no matter the dental, the standard, and so on. So they will have this kind of general schematic. But of course, in the general schematic, we have what we call the primary or the low voltage side. And of course, as we've just said, that this is just for providing, for heating the filament so that it can release the electrons. And then the secondary, which is the high voltage side, is to accelerate these produced electrons from the cathode to the rotating anode so that the X-rays can get generated. So those are the main sections of a simple X-ray generator circuit. But of course, this can always be expounded because There are so many electronic parts that can come in, but of course, this is just a simple schematic or the basic for an X-ray generator. And of course, another very important aspect or part of an X-ray system is the collimator. And its primary function is to collimate or to reduce the size of the radiation field to the area of interest. As we've just known that these X-rays are dangerous, so you always need to confine them where they should go. Otherwise, if at all they are scattered or they go anywhere, they can always be hazardous. So this collimator helps to reduce the scatter and also helps the image quality. And the collimator is also where the beam filtration, of course, is also installed. And this beam filtration consists of plates, which are mainly copper and aluminum, where the X-ray beam passes. So as you can see, it just confines the beam to the area of interest. And it's always attached to the tube. And of course, the tube is the one that generates these X-rays. And of course, you can always adjust the aperture depending on the area of interest that you want to X-ray. So there is what we call a horizontal and then the vertical kind of aperture kind of adjustments that you can always use to get the right field. So like what is shown in the image, of course, the beauty with the collimator, it also has a lamp which you can switch on and exactly know the indication of the area of interest where you can always send your X-rays. Now, the collimator has basically two main failures, and one of them is normally the bulb normally blows or a non-functioning bulb. So the other issue, of course, when you are replacing this bulb, you shouldn't touch with your fingers because of the oil that can create a hot spot on the bulb. So one has always to be cautious as he replaces this bulb within the collimator. So we've just seen a high voltage cable, but in addition to what we saw, these high voltage cables have to be handled very carefully because this can act destructively just from sweat on your finger, human finger. So if someone sweat, you can easily get an arc from this high voltage. And then they can also hold large capacitive charge even after the machine has been turned off. So one needs to have the right grounding procedures that need to be used to work in a high voltage safe environment. And sometimes they cannot be measured, of course, not sometimes. They can never be measured by our normal voltage meters. So they require specialized voltage meters to measure these high voltages. So they are really dangerous. One has to handle them with precaution, if at all he or she has. So this is a time for pause. Let me hand it over back to Foster to handle it.
Thank you very much, Henley, for your presentation. At this point, we have poll questions. So 3 poll questions have been launched. And for us to check if you're following or whether some things need to be repeated or further explained, please take part in the polls. So for you to access the polls, you will see an activities button at the bottom right corner of your screen if you're joining from a laptop. So there is a button that has a triangle, a square, and a circle. If you click on it, you'll see where you have polls. So please send in your votes. If you're joining from a phone, there's also an option button, a button with 3 dots. If you click on it, you'll see the activities button and then the polls. So let us please go through the polls. The first question says, which type of X-ray machine do you have at your facility? So you can answer that question. The second one reads, what do you think should be the next step in equipment planning after procurement is done? So there are also three options there. The last question reads, which of the following X-ray components is used to reduce the size of radiation field to the area of interest. So please, may you take part in these 4 questions. I see someone has raised their hand. Please just type whatever you want to say in the chat, and it will be addressed accordingly. As we are taking the poll questions, also be mindful that we will have a session of questions and comments at the very end of this presentation. So if you have a question or a comment, just write it down somewhere. You will be given a chance to ask or comment at the end of Henley's presentation. At this point, may I hand it over to Henley to proceed with the presentation. And Henley, if you are in a good place that you can turn on your video, may you please do so that our audience may appreciate whoever is presenting today. Over to you, Henley.
Okay, thank you so much. So now, thank you so much, Foster, for the polls, and so we can proceed. Now we have what we call the stand and rail system. So these are basically mechanical parts of an X-ray machine, which are standard. So these are movable parts, like the X-ray tube. One may need always to adjust or to move it. The collimator, the patient table, depending on the area of interest. And of course, the film or cassette, where of course the X-ray is of course mapped. So these are movable parts, and like any movable part, one needs to do good maintenance on these parts, like cleaning and greasing them, because sometimes they get susceptible to so many movement problems. So sometimes these mechanical parts get loose, and sometimes they jam up. So one always needs to always be to frequently check on them and see whether something could have happened, or something could even stuck them even as one moves them. However, sometimes there is what we call a sensor. So sometimes these mechanical parts are also affected by sensors, which sometimes get defected. So especially with the table movement and so on. So if there is that challenge, then if the sensor, of course, gets disrupted, then it will also hamper the movement of such mechanical parts. Now, the X-ray rooms normally, of course, one has always to be cautious, because these walls and doors of an X-ray room have always to be shielded with lead to protect the staff as well as the patient. And of course, the lead, of course, is able to absorb these X-rays so that they don't go through. Of course, the other very important aspect is sometimes as you move this tube, like for example, in this stand, some of these cables may drape, and of course, things can get stuck in here. So one has always to be very precautious while moving these kind of movable parts. And of course, the door has always to also be very closed, especially when you are taking X-rays. The beauty is some of now the modern systems, of course, they have an interlock, of course, which connects with the door. So if the door is not well locked, then still nothing will expose. But sometimes if you don't have that interlocking mechanism, then sometimes you have always to be precautious about how the door is closed to avoid the X-rays from getting astray. Now, how are these X-rays detected? So we have what we call photographic films, and these films are not sensitive to the X-rays. So 98% of these X-rays would go through them without interaction. So the way they are designed, they have the intensifying screens. So these intensifying screens are mounted on this fluorescent material in front of the film, and their role is basically to convert the X-ray photons into visible light photons. And so the amount of light that is produced is always proportional to the amount of X-rays. And in the process, the light photons are the ones that get recorded onto the photographic film. And of course, at the end of the day, we can be able to have or to map out an X-ray image. So this is basically the general detection of these X-rays. And these films are normally, there's what we call the conversion X-ray detection, whereby this is the old school type that we've been using, cassettes, and these are light proof, and they have rigid containers that enclose. So you put the film inside, and they come in different sizes. So the different sizes can also help to map, of course, the area of interest that you are interested in. It can also come up with the age of the patient, because for a pediatric, you may not need a large cassette, whereas for an adult, you may need a large cassette. So all of that are some of the factors that radiographers look into before choosing a cassette. However, these cassettes must be strong, rigid, and durable, and they must provide firm pressure so that there is good contact between the film and the screen. Otherwise, if there is a gap in between, then what will happen, you'll find that the compromised image will always come up from the X-rays that get onto the film. So one has always to be precautious. However, with the advancements of the technology, we have what we call the computed radiography. So this has been there since now 1980s, and different generations of these digital X-rays have entered the market. So these computed radiography systems use PSP technologies in the cassette combined with a plate reader, and the X-rays normally get recorded and stored in the Sierra plate, and then they put this in the reader, and then the computer reads out. So basically, here the advantage is there is no need for a darkroom for those of you who have worked with radiology equipment. So you don't need to process your image from the darkroom. So you just take your X-ray image, and then of course it's read by the reader. And of course, as it's read, the image is sent to the computer, and then it's of course mapped out. But however, one has to, caution should be taken, because these CRC systems can have a damage onto the cassettes, and this can cause artifacts. So the reader can have problems, and this can be usual. So this, however much these cassettes are really robust enough, or they have brought lots of changes, sometimes they can be delicate. So one has to handle them with a lot of care. Now, we also have what we call the digital radiography, or the DR systems. So the only difference that these DR systems have compared to the CR is that for them, they don't have a reader. So they use direct digital readout from the detector into a digital signal. And so this method, there is no need for a separate reader. And there are several technologies used, and some of them are under development. So in terms of space, this is quite a smart option, because you don't need a reader like the one we've seen in the previous slide. So you just take your X-ray, and then you can be able to map it out or read it out from the computer, and then be able to get to see the image. So if these digital detectors capture a good image, then they work. Otherwise, you may also need to replace them. Unfortunately, maybe things have changed. They can be repaired, but it has been quite tricky to fix them because of the intricate electronics that's involved in these systems. Now, digital X-ray systems, of course, in comparison to the conventional ones, have brought drastic changes, especially in the imaging world. And the main value of these various detectors in digital radiography is not so much on the improved image quality, but the ability to communicate. So you can communicate, you can process, you can archive images with the computers. So such hospital computers known as PACS systems, these of course have been known to be in rich countries, but of course they have come up in our low and middle income countries. So not only the quality of the image, but these digital systems have brought tremendous changes, whereby the imaging, of course, gets improved. You can integrate the network, you can have different archives, and of course the workstations. One can, of course, work from anywhere using these systems. And of course, computer programs are used to call up different images, but through that you can always improve, of course, on the communication. And of course, even the radiographers or radiologists can at least share ideas through this kind of digital X-ray system. So there is quite a considerable kind of change that these systems have brought up. Now, of course, on the other part of the X-ray system is the X-ray control unit. So these simple X-ray systems normally, they have the voltage or the filament current and X-ray pulse with it, which are normally entered. So what normally is entered is normally the KV or the MA and even the time. Now, however, with modern systems, of course, there is an advancement in the technology. So you may just enter one parameter and the other one can automatically set. So sometimes you can even just enter the body part and then it can help to automatically set the parameters that part may necessitate for a good X-ray. So technology has brought a lot of changes and simplified at least radiology kind of systems in a way. And of course, still, even if there are changes in technology and advancements, there are some common faults that one always has to bear in mind. And some of them, the common ones are no exposure. Sometimes it could be poor quality images. Sometimes the mechanical failure, as you've seen some of the mechanical components. And of course, there are some common causes also. And the common causes are normally user error, because especially now with the programmed X-ray systems, which are advanced nowadays, sometimes one can choose a wrong technique, and this wrong technique, of course, can hamper the operation of the machine. It could be a high voltage transformer which is failing. It could be the X-ray control failure. It could be, so those are some of the common things. So when I say common, I just imply that if at all something happens to an X-ray machine, don't take it to be so abstract. So sometimes first check on these common issues, because normally this is normally the cause of this problem. So that's the common, that's the notation of common that I'm trying to bring out. So if there is no exposure, of course, it could be the generator control which is failing, and it could be the safety circuits which are failing. So some of those things can be checked out. Sometimes it could be cable problems. Cables cable drapes get caught. Sometimes power cables get stretched or broken. Sometimes they get flexed. So some of those things are the common checks that one needs to do before taking the problem further. And of course, there are some rules here when you are trying to troubleshoot an X-ray machine. The first rule is knowing your machine intimately. Of course, this is an experience that one has to build, but this knowledge really supersedes it all. When someone knows the machine very well, when someone keeps the records very well, when you can gather all information that's available about the machine, when you can reproduce the actual failure, because sometimes these failures come, but sometimes they clear with time and you can't know what happens. But if you can reproduce, that could also be a great troubleshooting way. Isolating from the system knowledge, like the subsystem you suspect, troubleshooting the component level, rather troubleshooting at the component level, verify that the suspected component is bad, check the new component functions correctly, test the system and compare with the documentation file. So these are generic rules. Of course, people have adopted different methods, but these are really quite also handy in addition to what others have to at least help in the troubleshooting procedure. So of course, the manual can also bring out a lot with the X-ray troubleshooting. And of course, there could be different solutions or different procedures of working out different problems, like X-ray unit doesn't switch on, X-ray machine is not exposing, X-ray image quality, and so on. So the manual can get the details, But sometimes if you first look at the common problems that come up and what caused them, you can also add on to what the manual provides and so on. The other issue, of course, is preventive maintenance, or PM. Now, this is a very important issue because, of course, if you don't maintain anything, even if it's your car, you don't expect good results out of that. So even an X-ray machine requires at least once or twice a year PM for it to work normally. So a full PM can take several hours to 2 days to be complete. So it may take some time, but that time may be rewarding in the long run. So you have to, first of all, get to know the instructions from the service manual before carrying out this PM. And this includes activities on the main system components, as well as the automatic exposure controls and image qualities. Of course, there are basic things that one has to do, like vacuuming dust and dirt, checking that all wires are well connected, checking all the mechanical parts are really in good state, checking the alignment, checking the lamps and indicators, checking of various modes of operation, oil level in the transformer, lubricating, applying touch-up paint to the equipment scratches, quality, and also even cleaning the floor. And these are some of these highlights, or the common highlights that one always has to embrace. However, one always has to be precautious that high voltage work requires more training and special tools, as we saw. So if at all you don't need to touch the high voltage cable or generator, please do not touch it, just for safety purposes. Now, we can have this maintenance, of course, broken up. You can have the daily maintenance, you can have the weekly, you can have the 6 monthly, but of course, all of this can help in the performance of an X-ray machine. Like the daily, you may have to clean the dust, remove any tape that could have been left out. Visual checks, like checking all the parts are present and connected, checking that tables are not twisted to other cables, and of course, functional checks, checking on power and checking all indicator function well. The weekly can also still involve cleaning, visual checks with the plug, cable sockets, knobs, lead aprons, the table, and so on. Function checks, if the machine hasn't been in use, it could have worn out and so on, especially in regards to the apron. So the collimator bulb, you may also have to check and replace. Now, of course, the key important thing is the 6 monthly. So this might be called a standard PM, which may require a biomedical technician who is well experienced to be able to check on the details where possible. Still, safety is very important. One has to be very precautious while handling X-ray machines. So you don't need to touch high voltage, because they can cause a fatal death out of it. So one has always to be safety cautious while handling these machines. But of course, still, the health workers, there are ways there are ways that they can use to protect themselves from these dangerous X-rays, like the mobile shield before exposing. Sometimes the workers have to dress using the lead apron. There are sometimes the protective lead gas spectacles or goggles. But of course, there are also what we call the badges. So these badges can also, or we call them personal dosimeters, so they can also be put on by the radiographers or the other workers to tell, because there are some spots that you may not know that the dose is intensive at this point. So these dosimeters can help you to tell that, to at least guide you where there could be changes. Then, of course, performance monitoring. Of course, this, of course, rhymes with your machine. One has to know the quality of his machine. So if the quality is compromised, you can always get to know the optical density change. And of course, one can always tell that my machine is getting compromised and so on. Still under performance monitoring, image quality. Of course, this is the end result of an X-ray machine. Image quality is what you tell from, but there are some factors that can influence this quality, like the generator, the tube, the collimator, the distance, the patient. So all these factors can, of course, culminate to the image quality. However, the most common image quality problems are the processor. For example, for those who are using the conventional processing methods, the data chemicals or the temperatures which are not right, they can compromise the quality. The technique, for example, when I talk about technique here, I talk about the KV, the MA, and the time. If it's all manual, so if someone wrongly sets them, then that can also cause a compromise. Then the patient motion and also the film and cassette, of course, positioning can also affect the quality of the image. So that's it. Thank you so much. And I appreciate the audience, and questions are welcome.
Thank you very much, Henley, for the wonderful presentation that you've given to our audience today on understanding the technology behind X-ray medical equipment. At this point, before we go into the questions and comments session, let me just take two more poll questions. So as we are launching the poll questions, please, if you have a question or a comment, you can raise your hand or you can paste it in the chat. You can also use the Q&A section to ask your question. So two more questions have been launched under the pause. The first one is asking, what is the most common problem with X-ray tubes? The second question is asking that, did the webinar meet your expectations? So please also send in your votes as if the webinar has met your expectations. As we're taking these poll questions, I see we have a hand from Goodluck Oboro and Robert. But before you come in and ask, let me also just inform you that we will post a link in the chat. This is an attendance sheet that we will use for us to determine who gets the certificates. Remember, as we were introducing the theme topics, we promised to you that at the end of every theme section, we will be delivering attendance certificates. So make sure at the end of this call, before you leave the call, you attend to the attendance form. At this point, let me give a chance to Goodluck. You can unmute yourself and ask your question. Goodluck.
Thank you very much. Thank you very much. Good afternoon, sir. My teacher. Am I on?
That's Goodluck.
Yes, am I on, my teachers?
Yes, just try to raise your voice a little bit.
Yes, okay. So my first question is, during the lectures on X-ray tubes, the image went off, so I could not get the beginning part of the X-ray tubes. Then secondly, does the mobile X-ray machine have the generator? Does the mobile X-ray machine have the generator? Then again, sometime in my facility, someone came to repair and work on the mobile X-ray and said you need to discharge the batteries first before you can carry out the maintenance. So I don't really know, how to go about it. Those are my questions.
Goodluck, I hardly got your questions, but maybe Henley, if you did, you can attend to them. But just to answer on your first question about the image that you didn't follow very well. At the end of this course, we usually post the recorded video on our YouTube channel. So you can just follow our page and then you'll find the video and you can see where you missed. Henley, maybe you can take the other two questions if you got them. Otherwise, good luck. I think you can just paste them in the chat. Henley.
Yeah, thank you so much, Foster. So thankfully, I hadn't had the first question, but I think, Foster, you had it well and you've answered it. So the second question, which I vaguely had, was, does the mobile X-ray have a generator? So yes, it has. So a generator is a generic part of an X-ray machine. So an X-ray machine, no matter what type or what modality, it must have a generator. Then, of course, you are asking about the discharge. When someone came, I think, and told you that I need to first discharge the batteries for your mobile X-ray machine before working on it. I don't know whether that's what you are asking, but if that was what you are asking, is the reason for the discharge, of course, is to provide a safe environment. Of course, as we've said, these are high voltages. So some of these capacitors, actually, they are normally capacitors. Of course, they contain charge, and anything, as we've seen, even just sweat in your hands or fingers can create an arc. So, if someone is to work safely, I think discharging them would really provide a safer environment for at least a better troubleshooting mechanism. So I don't know whether I've answered right, but that's how I understood the questions. Good luck.
Yes, you
Thank you.
answered right. You answered right. So, a follow-up question. Sorry, follow-up question. Yes, a follow-up question. Sorry.
Before good luck, before you ask the other question, I can firstly take the other questions from the other people, then you can come back. So before you, good luck. I also saw a hand from Robert. And before Robert comes in, there is also another comment in the chat from this one. From Doto Atumani. He is asking you, Henley, if you can say anything about grid. Anything about grid. So maybe in a minute, you can just talk about it. And before Robert also, the link has been posted in the chat. That will take you to the Google form for you to fill in your attendance. So make sure you fill in this form before you leave this call, because if you don't fill this form, then you won't be considered when we are delivering the certificates. So Robert, you can ask your question, and Henry, you take them together with the comment from the chat. Over to you, Robert.
Thank you very much, Chair, and thank you, Henry, very much. Henry is my colleague, and every time I've been asked around any questions to do with X-rays, I say yes, I can deal with it, and the reason because I can deal with it is because I have Henry. And I've always wondered, if I want to set up an X-ray facility, where do I start from? And besides, where do I start from? How do I keep it going forever? Because this is a question that I see getting asked to me all the time. I want to have X-ray in my hospital, in my clinic. Where do I start from, and how do I keep it going on forever? And how do I stay in business? I hope, Henry, you can help me to answer that.
So can I go ahead, Foster?
Yes, please.
Okay. Yeah. So let me start with Toto Atumani. I'm sorry if the pronunciation is not right, but you requested me to talk something about the grid. Of course, given the time factor, I couldn't talk about much, But a grid, of course, is an advanced technology. And the grid basically helps at least to capture what we call the stray X-ray doses. So normally the grid is put, of course, in the cassette X-rays. And the design of the grid, of course, it has arrays. And these arrays are able at least to get those stray X-rays, which of course are not wanted to get to the X-ray film. So that in other words, the catchword for the grid is it helps at least to sieve. It's like a sieve. It sieves the doses that are unwanted to get to the film, and then of course it absorbs them, and then of course it only allows only the doses that are wanted, so that you can have a good mapping of your X-ray system. But of course, this is an advanced technology that also brought in at least tremendous changes in the X-ray world, especially in the image acquisition. Yeah, so that's it about the grid. Now, thank you, Dr. Robert. One thing I'm happy Dr. Robert is part of it. Dr. Robert, of course, he said I'm a colleague, but Dr. Robert is my PhD supervisor. So I'm really humbled for him being part of this discussion. And thanks so much for your kind comments. So Dr. Robert, of course, asked, where do I start? That's quite a powerful question. But of course, the way when we talked about the first slide, the planning, I think, is one of the key aspects that one should always start with. And the planning, of course, involves quite a lot. But I would think that, first of all, one has to bear in mind about the type of population of the X-ray patients that he or she hopes to take. Because you may find that this population can always dictate the type of machine that you'll acquire. And of course, that will still further get to even in the preparation of the room where the machine will go. So one has always to know, if at all I'm to get an X-ray machine, what type of machine will I get in terms of the services that it will give. For example, it can be a Gen X-ray, as we've seen, or it can be an advanced one, maybe for fluoroscopy, or it can be a mobile, whereby someone wants to take simple exams, maybe in the wards and so on. So all of that can dictate the way forward about how to prepare, where it will be, and of course how much money it will cost, and of course the service that will be required in the long run. Of course, as a technician, that's very important. And of course, it can even go further to even decommissioning later on. If at all I'm to sell off this machine and I have the value of money, of course, given what it produces. So of course, that also connects me to how do I keep going forever, or how do I keep in business? So still the planning can also guide you, because if at all someone didn't plan well initially, then you could find that probably the machine that he bought, he's not getting the rightful satisfaction from the customers who are the patients. So if this rightful satisfaction is not coming up, then the customers will go away to another maybe imaging facility. And in the long run, he will have wasted his money. So I think all lies in the planning, the initial planning. And of course, even in the planning, you have always to deal with the right people. Because sometimes if someone is not knowledgeable about this X-ray machine, he may not give you satisfactory information. So these people, it might look as though it may not make sense initially, but in the long run, this planning can really be rewarding after getting exactly what you needed. So I think that's how best I could answer that, Dr. Robert, but thank you so much for those insightful questions. And Toto Atman, over to you back, Foster.
Thank you very much, Henry, for taking those two questions. And thank you very much, Dr. Robertson, for your compliments and for your question. Of course, we have run out of time, but I would still ask good luck to paste your question in the chat or send us via email so that we don't consume much of the time. Other than that, if you have any other comments based on this scope, based on presentation done by our speaker today, Henley, please feel free to email us at info@oxygenalliance.org. And if you have any further questions based on this presentation, you can also send us your questions via our email, helpdesk@oxygenalliance.org. If you want to follow up today's presentation, you can also go to our YouTube page where the recording of this talk will be posted. Otherwise, thank you very much for participating in this talk today under the X-ray medical equipment. You have been a wonderful audience, and we wish to see you in the next one. Thank you very much. From Oxygen Alliance, goodbye.